Hello, future engineers. Welcome sa itong padayon nga example sa itong topic on horizontal sharing stress. So, let's proceed sa itong sample and then let's start again to solve. So, this will be our sample problem number 5. So, we have a T section. So, as shown here on the right side of the presentation, natay T ka section. So, compare sa itong previous na section, if you notice, kani siya is nasa murag duha ka section, no? Kaning upper nga rectangle and then kaning lower nga rectangle. So generally atong ginagamit di ba earlier sa atong samples is that regular polygons like a regular rectangle, circle or a regular triangle. Now this is a T section. So ato na siya ginatag og T section. So before we begin, ato sa ning panganlan no kaning duha ka part. Kaning ibabaw ginatawag na nato og flange. And then kani sa ubos ginatawag nato na og web. So take note of this one. Okay, ato man ni siyang magamit all throughout if we are going to tackle or talk about this T section. So okay, let's read the problem. Sample problem number 5. We have a T section shown here on the right side. And then is the cross section of a beam formed by joining two rectangular pieces of wood together. The beam is subjected to a maximum shearing force of 60 kilonewton. Show that the neutral axis is 34 millimeters from the top, and we have the centroidal we have the moment of inertia along with respect to the neutral axis is equal to 10.57 times 10 to the 6 millimeter to the fourth. Using these values, determine the shearing stress at the neutral axis and the junction given the two pieces of wood. So again, so atong first good button is that ato sa ilista no ang given tato. We were given a T section, so mo ginatong first na gihatag, and then later on ito pa given. You also have a given value of the maximum shearing force V, which is equal to 60 kilonewton or 60,000 newton. So what we were asked about, so ingon niya, show that the neutral axis, so mo ang gias no, ipa-show sa to nga, ang neutral axis daw is 34 millimeter from the top. So if this is the top, and then for 34 millimeters, so that is somewhere dire. 34 millimeters daw from the top ang neutral axis. So na-address in neutral axis. And then our moment of inertia along or with respect to the neutral axis is 10.57. So ang next then giasa to is that this one, the shearing stress at the neutral axis. And then the second one is the shearing stress at junction. At junction between two pieces of wood. So if you notice no, duha mo gini siya ka pieces of wood nga mura lang siya og gi-connect. So ato na siya pangitaon kung unsa ni siya. Again, remember the top part of this one kaning nakahigda, we call this the flange, and then kaning sa ubos is the web. Okay, so let's start. So ato naman na lista ang given, then let's try to solve na din for what is being asked. Okay. So, ang first one, so if makita nimo we have area 1 on this side, ato ni pangalan ng ibabaw og area 1, kay duha man ni sila ka area. Anong kanang ubos, pangalan nato og area 2. Let's say atong establish ang ilang centroids kada area. So, let's say for area 1, iba yung centroid for area 1 is naa diri nga side, naa sa tunga sa area 1, of course. Diri. And then atong centroid for area 2 is napod siyang tunga. So, each of these section, kaning duha ka rectangular section, the web and the flange, has its own neutral axis. Kaning show na to diri, which is also the centroid. So, itong buhatonan is, i-determine na to ang neutral axis sa tibuok nga section. So, how are we going to determine the neutral axis of the whole section? So, dali lang siya, no, mura siya Varignon's theorem but applied the area. So we call this the moment area. Ato sa isulat, let's say that our area 1, so atong area sa first, that is base times height, that is 200 millimeters times 40 millimeters. So total for area 1 is 8,000 square millimeters. And then atong area 2 dayon is, that is base times height, so inyo makita, that is 20 millimeters. So, no, this one. And then times 100 millimeters. So that is equal to 2,000 square millimeters. Next is, kuha na to ang ilaang y bar 1 and then y bar 2. So, kaning y bar, so this is the the distance of their respective centroids from a fixed datum or datum. So since ato magiing so ang iyang gipa-prove diri is from the top man daw, so atong try na to ato ang fixed datum is from the top. So diri ta magkuha sa y1 ug ni y2. So for area 1, no, atong y1 or y bar 1 is the distance from the top from a fixed datum na to paingon sa centroid ni area 1. So ato ang y bar 1 is this one, and then our y bar 2 from the top, so mo ni siya ang y bar 2 na to from the top. So itong y bar 1 katunga lang na ni 40 millimeters, no, because 40 millimeters man itong height. So this is 20 millimeters. And then si y bar 2, so diri sa ubos, this is 100 man, katunga niya is 50. Plus 40, so this is 90. Di ay 90 millimeters si y bar 2. So si y1, that is, y bar 1 is 20 millimeters and then our y bar 2 is 90 millimeters. Next dayon is that, paano to ang total area? So, total area din na to, i-add na to na si area 1 plus area 2. Area total is equal to area 1 plus area 2. So, that is 8,000 plus 2,000. So, overall, that is 10,000 per millimeter. Now, by the moment area, we have, diba, the total area times its centroid or y bar is equal to the summation of the areas times its y bar sub n. So, total area na to is 10,000 times y bar, kanya itong ginapangita, is equal to area 1 na to, which is 8,000 square millimeters times y bar 1 niya is 20 plus area 2 na to is 2,000 square millimeters times y bar 2 niya is 90 millimeters from the top. So, solving on, natin makuha nga y bar actually, which is equal to 34 millimeters from the top. Natin makuha nga yung ani. So, tumugin itong first buhaton, no? After we have written the given, next is pangitaon or illocate nimo ang neutral axis sa tibuok section. Again, this section is different, no? Duha man ni siya ka kung yung tanawon, duha ni siya ka area, duha siya og size. So ang buhaton is after nga we have listed the given, and then you locate the neutral axis. Since this is not rectangle, so wala gyud sa tunga ang neutral axis sa tibuok section. So akong first gi-show is that pakita sa nako ang neutral axis ni area 1, which is sa tunga, pagitawag na tog sentro, and then ni area 2. So ato din gipangitan og resolve neutral axis ang usa ka section. So atong na-solve is, that is 34 millimeters from the top. Okay, so ato na siyang, so importante kani siyang neutral axis kay ato maning magamit sa pag-solve later on sa ato ang shearing stress. So ato na locate nga 34 millimeters from the top. Therefore nana somewhere diri ato ang neutral axis. So this is our neutral axis, and from the top, that is 34 millimeters. So next gipangita sa to is ang this one, the I and A, or the moment of inertia. So diba ito ang transform moment of inertia I is equal to the centroidal moment of inertia plus AY of n squared. Or other niya nga formula, ICG plus AD squared. Kumala siya. So ato tagsa-tagsa gyapon kuhaan nato ni ang duha ka section each og moment of inertia, and then afterwards iusa nato siya para natay moment of inertia for the whole section. So let's start for our area 1. So atong area 1, so atong central moment of inertia, that is 1 over 12, and then BH cubed, di ba? BH cubed plus AD squared. So sa area 1, so that is area 1 squared times D1 squared. The kaning si D here is mo ni siya ang distance from the centroid of this of the polygon. Let's say this one rectangle, mo ni ang centroid paingon diri sa neutral axis. So mo ni siya si D1. And then si D2, this one for area 2, is ang centroid sa area 2 paingon sa neutral axis. So mo po ni si D2. Okay, let's start with D1. So that is 1 over 12. Atong base is 200 millimeters times atong height is 40 millimeters cube plus area na to, di ba? Area 1 na to is 8,000 times iya ding let's say moment arm is distance gikan ni centroid paingon ni neutral axis from the area 1 is that is 14 millimeters. So that is 14 millimeters. So asa nagikan sa 14 millimeters? So di ba that is a rectangle. And then anay centroid kani siya specific rectangle. And then kabalot nga si neutral axis is somewhere diri, and then that is 34 millimeters. Ato ang kani si D is kani siya nga distance si D1. So since this is sa ibabaw ani this is 20 millimeters, so therefore ang remaining distance paingon niya kang neutral axis is 14 millimeters. So that's why nag times 14 ta, and then makakuha tag I1 na to, or moment of inertia 1 na to, which is equal to 2,634,666.667 millimeters to the fourth. So be careful with your units ha. Here atong ginagamit with I is millimeters, and then for our shearing force is dapat naka-newton siya. So kung kilonewton siya, dapat i-convert mo into 1,000 newton, 60,000 newton. Para diretso na ang result, megapascal. Next is the area 2, kuha na to, moment of inertia. Same yapon, 1 over 12, and then BH cubed din. So atong base for area 2, kani this one, so atong base is 20 millimeters times iyang height is 100 millimeters. And then cube plus AD squared. So ang area niya ni area 2, that is 2,000. Tapos yung moment arm kani si dito nga atong gipakita dire. So this is 50 plus, so gikan sa ubos paingon diri pasaka, that is 6 millimeters. So plus 6 millimeters ato pa times 56 na dire. Squared. So nakalimutan squared dire sa pikat. So ato ang moment of inertia, transfer moment of inertia for the second nga koon rectangle is equal to 7,938,666 sorry 7,938,666.667 millimeters to the fourth. So para makuha na to ang moment of inertia for the whole section, or let's say the I total, i-add na to si I1 plus I2. So I1 plus I2, this one, both of this, so that is equal to 10,573,333.334 millimeters to the fourth, or approximately equal to 10.57 times 10 to the 6 millimeters to the fourth. This is our I, and then this is our Y bar nga 34 millimeters from the top. So mo siya ang ato ang na-show diri nga ato ading distance of the neutral axis from the top bar is 34 millimeters, and that our I and A, or the moment of transfer moment of inertia for the whole structure, is 10.57 times 10 to the 6 millimeters to the fourth. Okay. So next, unsay buhaton nato. Ako lang ilista balik diri para dili ta malibog. We have a given nga 60,000 Newton, and then ato ang I and A is equal to 10,573,333.34 millimeters to the fourth, or equal siya ni 10.57 times 10 to the 6 millimeters to the fourth. What else atong given? You also have the area 1, which is equal to 8,000 square millimeters, and area 2 is equal to 2,000 square millimeters. But yes. So again, atong gipangita is for A, the shearing stress at the neutral axis, and for our B is the shearing stress at the junction of two sections. Okay. Ako lang i-drawing balik, no? So we have this one, and then apoy nga ni sa ubos. So this is the centroid for the area 1, this is the centroid for area 2. Kani siya sa ubos, this is 20 millimeters. Height niya diri is 100 millimeters. And diri sa ibabaw, we have 200 millimeters, and then height niya is 40 millimeters. So for the first one, we need the the shearing stress at the neutral axis. If you remember, ato ang neutral axis is somewhere dire. So this is 34 millimeters from the top. And if you remember, ato ang shearing stress is equal to VQ over IB. So we already have our V, our shearing force. We have our I, this one, the I and A, the transform moment of inertia for the whole section. Ato ang B, for the let's say area 1 is 200 millimeters. What else? Atong isolve na lang diri is ang Q. So Q, di ba, is equal to, so Q at NA is equal to area Y bar. So sa man natong gamiton nga area ani, at the neutral axis man daw. Atong gamiton nga area, if we look at this section, so this one, kani ibabaw sa neutral axis, this one. So ang area ana, that is just equal to, ato ang base is 200 millimeters. Times ang height niya, that is 34 millimeters. Okay, kaniya naman nga area, that is 34 millimeters man. Times ang iyang Y bar, distance niya kang centroid paingon ni neutral axis, again, pila to, that is 14 millimeters. Ano no? So dili na din siya kuan. Dili na ni siya 14 millimeters because bago naman ato ang area. So ito ang new area is, di ba, naana diri. So gikan sa ibabaw paingon diri sa centroid sa itong new area, that is 17 millimeters. So 34 man ni siya yung height. Nato pa yung distance paingon kang neutral axis is also 17 millimeters. So itong Y bar is 7 times 17 millimeters. So ito ang moment area Q is equal to, so at the neutral axis, is equal to 15,600 millimeters to cube. So remember the units, that is millimeters. Since we already have our Q, nanatay V, nanatay I, we already have our B and then the Q. So ato na masolve ang ato ang shearing stress at the neutral axis. So that is equal to VQ over IB. So don't forget this general formula. Itong V is 60,000 newtons times our Q is 15,600 cubic millimeters over ato ang resolve or transform moment of inertia with respect to the neutral axis. That is 10.57 times 10 to the 6 millimeters to the fourth. Then ang ato ang B or the base is 200 millimeters. Ato ang FV or shearing stress at the normal axis or the neutral axis, that will be equal to 3.28 megapascal. Muna ito ang answer for our first nga kuan. Kung sige pa nga isa to nga question, no, the shearing for stress at the neutral axis. Next na po na to kuan is the kuan at atong adjunction. Okay. Drawing po na ko balik ha. So adjunction da kuno of the two woods. So again, this is 20 millimeters. And then height ani sa iyang ikadua is that is 100 millimeters. Height na to for area 1 is 40 millimeters. And then itong width diri sa ibabaw is 200 millimeters. So we have our neutral axis on this side. We have the NA. So for our B, we need the shearing stress at junction sa between two pieces of wood. So again, for FV, we have VQ over IB, di ba? So our V remains constant. So that is equal to 60,000 newtons. Our I, with respect to the neutral axis, as usual, that is 10.57 times 10 to the 6 millimeters to the fourth. What else? So ito ang B. So again, kung diri na ang iyang pangay is diri daw kuno sa junction. Diri. Pila daw. So on this side, natay duha ka shearing stress. Shearing stress nga gakahitabo diri sa web, the flange, and then shearing stress at junction diri sa web. So duha atong isolve. So let's start solving for let's say our shearing stress at junction for the flange. Kaning rectangle sa ibabaw. So for this rectangle sa ibabaw, to ang yung base or width is equal to, that is 200 millimeters. How about the Q? So unsa man ato ang Q? So ato ang Q for this one equal to a Y bar. Unsa man ang area itong gamiton? So kani at two sections naman daw, so pwede ra itong gamiton nga area is kani si area 1, pwede po si area 2. Sige, para maimba itong gamiton si area 2. So ang area 2 na to, that is 2,000, di ba? 2,000 square millimeters times Y bar. So again, unsa gani si Y bar? Ang distance ni centroid ni area paingon kang neutral axis. So for our Y bar 2, or para dire sa area to nga Y bar, that is, so dire natay 50 millimeters plus 6 millimeters dire sa ibabaw. So this is equal to 56 millimeters si Y bar di ay times 56 millimeters. So natay makuha ani nga 112,000 cubic millimeters. Sir, how about if kaning ibabaw nga area ako i-consider? What will happen? So for this one, if ibabaw nga area to i-consider, let's say kani si 8,000, so kani ibabaw no, that is 200 times 40 millimeters times pila to yang kuan, that is, so yang distance from the centroid to the normal axis, this one is 14 millimeters. So 8,000 times 14 millimeters na Y bar is still equal to 112,000. So isa ra constant si Q. So nanatay B, we already have our Q. So ato ang shearing stress at the flange, substitute lang nato ang values. We have 60,000 VQ over IB. Atong Q is 112,000. And then IB, atong I na to is 10.57 times 10 to the 6 millimeter to the fourth. And then atong B is 200 millimeters. So this is equal to 3.1788 megapascal. So this is for the plan. Next is the shearing stress adjunction for the web. So diri kay web naman kaning sa ubos. So ato ang B is kanina this one. This is the 20 millimeters na. Ato new B is 20 millimeters. Same ra gyapon ato ang shearing force is still 60,000 newtons. Atong moment of inertia transform, same ra gyapon, 10.57 times 10 to the 6 millimeters to the fourth. Q nato will still remain the same, 112,000 cubic millimeters. So just substitute this to the formula. Ang shearing stress is equal to VQ over IB. So that is 60,000 newtons times 112,000 cubic millimeters over 10 times 10 to the 6 times 20. So ato ang shearing stress adjunction for the web is equal to 31.788 megapascal. So this will be our answer for the second problem. So again, atong gibuhat first is that since this is not a normal section, this is a T section. We list the given, and then later on, gikuha na to kung asang location sa centroid for the whole section. So si area 1 na siya iyang own centroid or the neutral axis ni area 1. The area 2, it has also its own neutral axis. But gikuha na to siya resolve Y bar or location sa iyang neutral axis along the Y axis. And then, since laylay man silang shape, laylay silang position, laylay silang itsura, we get their transform moment of inertia, tagsa-tagsa for the rectangle 1 and the rectangle 2. And then, gi-add na to siya to get the total moment of inertia for the whole section. Nagkuha na to, nagkuha din tag shearing stress at the neutral axis. So same ra yung mga formula VQ over IB, and then shearing stress at the conjunction for the flange to here and for the web. Okay?